Today we are going to talk about how to use rtbricks to simulate both ISIS and LDP session together. I have posted videos on the channel that speaks about how to simulate BGP sessions, ISIS and LDP as separate protocols. Now, many times when you are doing performance testing or scaling testing on a product, you may need to have these protocols working in tandem. ISIS, LDP together, BGP also if needed, you can add it together. In this example, we will try to demonstrate how to use ISIS and LDP together from rtbricks, which is installed on an Ubuntu, and the sessions are established towards Juniper and how the routing information is also passed over. So quickly going into the diagram to explain the setup, you can see rtbricks is here, which is connected via ENS20 interface towards a Juniper device here, which is ET003. Of course, instead of Juniper, you can have any device. In this case, I'm using Juniper. Now quickly going into the configuration. So first of all, on the router, I am checking if there's any sessions. There is no ISIS and no LDP sessions at the moment. So on the rtbricks, the configuration that I'm going to invoke is the one here. So ENS20 is the network interface, which has got an IP address of .3. It is pointing to the gateway, which is the router, which is .1. I have instance IDs defined for LDP and instance ID for ISIS. As you can see, it's 1. The level of ISIS that I'm running is 2. If you want to run a different level, like level 1, you can change it accordingly. Now on the LDP configuration, I'm calling that instance ID 1. lsr-id is nothing but the interface IP address of the rtbricks, which is here, as you can see. And there's a raw update file, which is carrying the LDP root updates. The video that I have posted previously about LDP simulation explains how to generate this file. So if you have any questions on that, you can refer to that video. The same is the logic for ISIS. Again, instance ID 1, which is defined here, as you can see here. And then for ISIS also, we have given a system ID. This is a unique ID. I'm not trying to use the same address as the LSR ID, but if you want, there is no problem, you can use it. In this example, I'm just using a different ID, system ID and router ID. As you can see, it's 192.168.1.1. The host name of the ISIS is going to be called R1. It is on area 49002. Hello padding and lsp-lifetime is given here. So again, for ISIS, the information that I want to pass on through the ISIS session is on this G.mrt file. How to generate this is also explained on the ISIS simulation video. So please refer to that if you'd like to understand how this file is generated. Eventually, the system ID, this detail is also generated through this file LDP update generation process. So the other video on ISIS simulation will help you understand what the system ID is also. After that, I just have a stream of traffic that is running for this destination. So now I'm going to start the BNG blaster and I'm going to call this file. So what is happening right now, you can see I have a stream of traffic which is 1000 bytes, and that is what is established here. You can see I have 1000 packets in and out. And let's check if the protocol sessions are all formed. So now I'm going to check ISIS adjacency. There you can see ISIS adjacency is up. Now I'm checking on LDP, that is also up. So as you can see here, as the rtbricks is running, we have these packets that I'm sending. And if I look at the routing information for that particular prefix for which I have traffic, you can see I have an ISIS route and an LDP route. So typically this is what you would have in a normal production scenario. For a given route, you will have an ISIS or an OSPF route, and a corresponding label entry is also available. Hope you find this useful. Bye for now.